one more example. Same picture, and there's W, the route that is broken. We can't take that connection. And then there's a point A close to it. So the question that I wanted to ask was, how many routes are there if W cannot be used still, but you must go through point A? So you're creating a network route that uses point A. Basically two routes, one to get to A and one to finish from A to the finish. So the way you do that is you first decrease the total. You start with all routes that must go through A, and then we'll subtract the routes out of that total that use W. So you subtract the routes that go through A and through W. So here's the way to get the routes through A first. So I'm saying it's 10 choose 6 and 7 choose 3. That's because if I look back at the picture, to get to A is at 6, 4. So there's 10 steps to get there. And I need to choose 6 east steps. Of course, 10 choose 4 would also work, but I used 10 choose 6. And then to finish, it's a little harder because it goes from 6, 4 to 9, 8. So I could just count that by hand. 3 steps over and 1, 2, 3, 4 steps up. So that'll be 7 choose 3. So that's why we have 10 choose 6 times 7 choose 3. Then we want to subtract all the routes that go through A and use W. So A is up above W, and so it is possible to go through W first and then hit A on your way to the finish. So it starts out counting the ways to get to the beginning of W. That's 7 choose 4 from 0, 0 to 4, 3. Then use W, that's the 1, 1, takes you to 5, 3. And then you have to go through A on your way to the finish. So from 5, 3 to A, there's only 2 ways to do it. 2 choose 1. It's just that single box. There's 2 steps, and one of them has to be east. And then finally, to finish from A to the finish line, there's 7 choose 3 again. So that's going to be a smaller number, and when you subtract them, that's what it looks like. 7350 minus 2450 gives you 4900 total.